We'll be taking a much different approach from our textbook in this section. The textbook uses several theorems along with a guess and check method to find the exact zeros of polynomial functions. We'll be taking a technology approach to finding these zeros. You'll also find when you do your homework that since we're using such a different method, the help aids, the learning aids that are normally available would not be helpful in this section, so those have been turned off for this section only. To find the zeros of a polynomial, first we'll start with two properties that all polynomial functions have. First, if a polynomial has a complex zero, a plus bi, then a minus bi will also be a zero. Second one is that if a polynomial has degree n, then the equation will have n zeros if you count the repeated zeros separately. We'll use the following procedure to find the exact zeros of polynomials. Okay, first we'll use our calculator to graph the polynomial and then find all the exact zeros that we can. Step 2, if additional zeros still need to be found, we'll use the zeros we found in step 1 along with synthetic division to find a quadratic factor for our polynomial. And then step 3 is to set our quadratic factor equal to 0 and solve for the remaining exact zeros. So example 1, f of x equals x cubed plus 2x squared minus 5x minus 6. So the first thing is let's look at what the graph of this looks like. Okay, so go to y equals, clear anything that was there before, and type in x to the third power plus 2x squared minus 5x minus 6. Just to be sure that we're all looking at the same screen, press zoom and select number 6. Okay, so you'll see something like this, and you can see that we have x-intercepts here, here, and here. So we want to have our calculator tell us what those are. And if they're exact, meaning nice numbers or nice decimals, then we'll include those in our solution. If they're not, then that typically means that they are coming from a square root. So let's start with the furthest one to the left. We'll find that one first, and then find this one, and then find this one last. So to have our calculator calculate these for us, you want to get into the Calculate menu, which is above the Trace button. So press second, and then the Trace button. That opens up the Calculate menu. We want to select option number 2, calculate a 0. Okay, your calculator will now ask you for a left bound, and you should see a blinking cursor on your screen. So what you need to do is give the calculator 2 marks to look in between and find the 0. Give it a left bound and a right bound. And by left bound and right bound, what that means is if your x-intercept is here, you want to go to the left, and that means your graph is down here. And you also want to go to the right, and your graph is up here. So that's what it means by left bound and right bound. Okay, so left bound, I'm going to move my cursor over here. Okay, so anywhere below the x-axis and press enter. And then the right bound, move my cursor to the right. Anywhere up here, press enter. And the method we're taking, when it says guess, you can just hit enter at guess. And so it tells me x equals -3 and y equals 0. So x equals -3 is one of our exact zeros. Okay, second one, we want to find this 0 next. So you have to go back into the Calculate menu. Second, Calculate. Option number 2, find a 0. Okay, left bound is up here. And right bound, if I move to the right, I want to go below the x-axis. Press enter. And guess screen, press enter. And that tells me x equals -1 and y equals 0. And our last x-intercept right here, calculate number 2, a 0, left bound anywhere down here, right bound up here. And we get x equals 2. Okay, so for this problem, since we have x cubed, that means we're expecting 3 zeros, and my calculator gave me 3 exact zeros. For this particular problem, no other work is needed. Your exact zeros are -3, -1, and 2. So only step 1 in our 3-step approach is needed. Example 2, find the zeros of f of x equals x cubed plus 7x squared plus 11x minus 3. So again, start by graphing. So press y equals, clear the other function, and type in x cubed plus 7x squared plus 11x minus 3. Press graph, and you will see a graph that looks something like this. Okay, so to find the zeros, again, we can see 3 of them, so we want to see what those are. So calculate menu. Let's start with the one furthest left. Okay, to the left of this x-intercept puts us below the x-axis. To the right will move us above the x-axis. Guess screen, press enter. And it tells me -4.236068. So that is not an exact 0. So we are not going to include that one. That came from a square root, and we'll find that later. Our next x-intercept, second, calculate 2 for a 0. Left bound is anywhere up here. Right bound puts you below the x-axis. And that gives us x equals -3. So there's an exact 0. And our last one, if you test this one, left bound is anywhere down here, and right bound anywhere above the x-axis up here. Okay, and that's 0.2360678. So again, not an exact 0. So we have one exact 0 and 2 zeros that will come from square roots that we'll find with the quadratic formula in a moment. So once you have an exact 0, how you proceed with step 2, take your polynomial and do synthetic division using -3 as your 0. Bring down 1. -3 times 1 is -3. 7 minus 3 is 4. -3 times 4 is -12. 11 minus 12 is -1. -3 times -1 is +3. And -3 plus 3 is 0. Okay, we started with x cubed, so this will be 1x squared plus 4x minus 1. Okay, since you confirmed on your calculator that -3 is an x-intercept, that means you'd have to get 0 as your remainder, otherwise something did not go right. So through synthetic division, what you have figured out is if x equals -3, if you add 3 to cancel -3, you have figured out that x plus 3 is a factor, and 1x squared plus 4x minus 1 is also a factor. So if you take this second factor, set it equal to 0, and solve for x, that will give you your two remaining exact zeros. So let's do that. Our two remaining zeros, x equals opposite of b, negative 4, plus and minus the square root of 4 squared minus 4 times a times c all over 2a. Okay, underneath the square root, you'll have 16 plus 4, which is 20, all over 2. 20 is not a perfect square, but 20 you can think of as 4 times 5. Okay, so simplifying, negative 4 plus and minus, the square root of 4 is 2. Square root of 5 is a never-ending decimal, over 2. And then lastly, simplify our fraction looking at these three numbers. They're all divisible by 2. Negative 4 divided by 2 is negative 2. Plus and minus, 2 divided by 2 is 1, but because of the square root, you don't need to write the 1. And then denominator, 2 divided by 2 is 1, so that eliminates the need for the denominator. So our zeros are negative 3 from our calculator, negative 2 plus the square root of 5, and negative 2 minus the square root of 5. So there's our three zeros. Other thing in the problem is it says to write f of x in factored form. Well, factored form, we want to use our zeros. Okay, so negative 3, again, if you add 3, that gives you x plus 3. And our second factor that we wrote right after synthetic division, x squared plus 4x minus 1. So there's how to write the function in factored form. We use the same procedure to solve polynomial equations rather than just finding the zeros of polynomial functions. So example 3, we're asked to solve the equation x to the fourth minus 6x squared minus 8x plus 24 equals 0. So again, the starting place is to go ahead and graph this on your calculator. So y equals, clear your other graph, x to the fourth power minus 6x squared minus 8x plus 24. Press graph, and we see a graph that looks something like this. Okay, and so we really only see it crossing one place at the x-axis, and it actually looks like it touches. So if you ever have a situation where your graph appears to just touch the x-axis, what I would recommend is zoom in at that place and make sure that the graph only touches the x-axis. So if you press zoom, number 2 is zoom in. When you do that, you'll have a small blinking light, and you want to move that blinking light right to the x-intercept that you're trying to get more information about. Okay, so press enter, and it zooms in, and it shows you that it really looks like it just touches the x-axis. So let's zoom one more time, and that should pretty much confirm it for us. Okay, so yes, we've confirmed that the graph just touches the x-axis. Next, we need to figure out where does it touch the x-axis. It appears to be about 2, so let's confirm that. Let's go back to our graph, zoom 6, go back to the standard window. Okay, appears to be 2. I'm going to show you a different method on this one. Instead of doing calculate and calculating a 0, let's look at a table. If I hit second and then graph, that will open my table. Okay, and you may start in various places. So to get a standard starting place, let's set our table for some specific information. So if you want to do that with me, press second window. The first one asks you, where do you want your table to start? Let's start it at 0. And this second one with a triangle, that's the Greek symbol delta. So delta table is asking you, how much do you want the x values to increase by? Let's have it increase by 1 each time. Okay, so now that we've done that, press second graph again to open up our table. And you'll see in your table, you have x values and their paired y value. Well, the x value 2 is paired up with the y value 0. So that's another way to confirm whether or not a value is a 0 or not. Okay, it looked like on the graph that it was x equals 2. So if we go to the table and we see x is 2 and y is 0, then we've confirmed that what we're seeing is correct. Okay, and that's the only one we saw. So x equals 2. But remember, on our graph, that it touches the x-axis. Remember what we learned about multiplicity in section 3.2. So since the graph touches the x-axis, that means 2 is repeated twice, and that the factor x minus 2 is repeated twice. So we know 2 of our 4 zeros. So since 2 is repeated twice, we can do synthetic division twice with 2. So 1x to the 4th, we skipped x cubed, so 0x cubed, minus 6x squared, minus 8x, and 24. 2 on the outside, and then go through our synthetic division. 2 times 1 is 2. Add, we get 2. 2 times 2 is 4. Negative 6 plus 4 is negative 2. 2 times negative 2 is negative 4. Negative 8 minus 4 is negative 12. 2 times negative 12 is negative 24. 24 minus 24 is 0. We started with x to the 4th power, so this is now 1x cubed plus 2x squared minus 2x minus 12. Since 2 was a repeated 0, repeated twice, that means we can use this polynomial to do synthetic division again, using 2 again. So 1x cubed, 2x squared, negative 2x, negative 12, 2 outside. Bring down the 1. 2 times 1 is 2. 2 plus 2 is 4. 2 times 4 is 8. Negative 2 plus 8 is 6. 2 times 6 is 12. Negative 12 plus 12 gives us remainder 0. This was x cubed, and so this gives me 1x squared plus 4x plus 6. So using synthetic division twice, we're able to uncover a quadratic factor. So my polynomial can be thought of as factoring into x minus 2 twice times the quadratic factor we got, x squared plus 4x plus 6. So I already know that this will give me 2. Last thing to know is, what does this give me? So if we set this equal to 0 and solve using the quadratic formula, we'll have x equals opposite of b plus and minus the square root of b squared minus 4 times a times c all over 2a. Underneath the square root, we'll have 16 minus 24, which is 8. I'm sorry, which is negative 8. Very important, negative 8 over 2. Negative 8 is not a perfect square, but can be thought of as the square root of negative 4 times the square root of 2. So this will simplify to negative 4 plus and minus The square root of negative 4 is 2i. Square root of 2 is a never-ending decimal, all over 2. And then lastly, do these simplify? And yes, they do. They're all divisible by 2. Negative 4 divided by 2 is negative 2. Plus and minus. 2i divided by 2 will leave I. Square root 2. And 2 divided by 2 is 1, so we no longer need the denominator. So our solutions are x equals 2 twice. You don't need to write it twice, just once. Negative 2 plus I square root 2. And negative 2 minus I square root 2. So counting 2 twice, there's our 4 solutions to this polynomial equation. Our last example, example 4, we want to solve x to the 4th power minus 6x cubed plus 22x squared minus 30x plus 13 equals 0. So we will start by graphing. Y equals, clear our other graph, x to the 4th power minus 6x to the 3rd power plus 22x squared minus 30x plus 13. Press graph. We see a graph that looks like this, and again, it's one where it looks like the graph is touching the x-axis. So zoom in to make sure that it is. So zoom number 2, move the blinking light to where it looks like the x-intercept is, and press enter. Okay, so if we do it one more time just to be safe. Okay, graph's definitely touching the x-axis, and it looks to be touching at x equals 1. So if we confirm that, try the table way again. Okay, I see x equals 1, y equals 0. So one of my exact zeros is x equals 1. And since the graph touched the x-axis, that represents 2 of my 4. So like our last problem, we're going to do synthetic division twice. 1x to the 4th power, negative 6x cubed, 22x squared, negative 30x, and 13, with our 0 of 1 outside. Bring down the 1. 1 times 1 is 1. Negative 6 plus 1 is negative 5. 1 times negative 5 is negative 5. 22 minus 5 is 17. 1 times 17 is 17. Negative 30 plus 17 is negative 13. 1 times negative 13, negative 13. Add those together, and we get 0 for our remainder. So this is 1x cubed minus 5x squared plus 17x minus 13. We'll do synthetic division one more time using 1 again because it was a repeated 0. You can only use a number twice if it's repeated because it touches the x-axis. Bring down the 1. 1 times 1 is 1. Negative 5 plus 1 is negative 4. 1 times negative 4 is negative 4. 17 minus 4 is 13. 1 times 13 is 13. Add together, remainder 0. So we have, since this was x cubed, x squared minus 4x plus 13. Okay, so that gives us a way to factor our equation. We have, since x equals 1 is a 0, x minus 1 is a factor, and it's repeated twice. And our division gave us x squared minus 4x plus 13. So if I take my quadratic factor set it equal to 0, and solve, we'll have x equals, opposite of b is positive 4, plus and minus the square root of negative 4 squared minus 4 times a times c, all over 2 times a. Okay. Underneath the square root, you'll have 16 minus 52, and that's negative 36. So 4 plus and minus the square root of negative 36 all over 2. 36 is a perfect square. So 4 plus and minus square root of 36 is 6. The negative gives us an I all over 2. And 4 and 6 are both divisible by 2. 4 divided by 2 is 2. Plus and minus 6 divided by 2 is 3. So our solutions, x equals 1, 2 plus 3i, and 2 minus 3i.